So that's what's up with that. Cool. Hi, class from tomorrow or today, whatever, I don't understand. So we're going to be talking today about two kind of related things that have a big effect on photography, and that is focal length and resolution. And just like we did last class where I taught you a thing and then we went out and played around with some stuff, I'm going to teach you a thing and then we're going to go out and play around with some stuff, okay? Along with that, you folks haven't gotten your photos up to the Google Drive yet from last class, the 7-element photos. So we'll do that at the end of class too. So you'll take some new pictures and then you'll also have some the shots from last class to upload too, which is great. Okay, so we're going to start talking about the first kind of technical thing to do with cameras, and that's what's called focal length. Focal length refers to basically how zoomed in an image appears to be on a camera. And I'll show you this with both actual real cameras and how it applies to what you kind of think of as focal length on your phone, which unfortunately is filled with a bunch of misconceptions. But I'll actually teach you what all the stuff means as we go through this. So this chart that's up here right now looks kind of confusing. I'll refer back to this a little bit later and it'll make a lot more sense. But there's a couple of words I want you to be familiar with. First off, focal length is given in millimeters, which is kind of a funny way to do it. But this refers to the distance that the lens projects onto the sensor. Blah, 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 a bunch of technical crap. Basically, small numbers equal a larger field of view. Large numbers in millimeters equals a smaller field of view. Okay, what do I mean by field of view? Everybody, give yourself a little bit of room, and I want you to stretch out your arms like this so that they are straight across, okay? Now, here's kind of a fun trick. So for most people, we're going to do this and we'll figure out exactly what it is for you, but for most people, your fist held at arm's length takes up about 5% of your field of view, but I'll show you how to calculate this. So take one of your arms, make it into a fist, take your other fist and move it like this. So not like this in front of you, that doesn't do any good. So have your arms so they're straight out, then move a fist so that it's right in front of it. Now I want you to count, so right now this is 2, 3, 4, 5, 6. Basically you're going to count the number of fists that it takes to get all the way across the other side of your body. Go! You can't go backwards, yeah, so you want to go from this side to this side, basically.
I don't get it.
And they have to be all the way fully extended.
I got it.
Okay.
25. I got 15. I got 19. I'm at 25.
Okay, now, if you could do some quick math in your head, or some rough estimate math, this, if we're thinking geometry, is pretty close to a straight line. What's a straight line in degrees? 180 degrees. If you divide how many fists it took you to get all the way across to the other side from 180, you will get how much of your field of view your fist takes. So do that in your head. See if you can do that math. Divide 180 by whatever number you counted. Okay? Most people are going to be somewhere between 8 and 15 degrees. It depends on how long your arms are, and it depends on how big your fist is. Now, I know that mine is right at 10 degrees in my field of view. So if I were to hold my fist out at arm's length like this, I'm blocking Owen's head entirely. That's because at this distance that Owen is standing from me, he takes up 10 degrees of my field of view. This is my field of view normally, 180 degrees, which you can usually see about 180 degrees without moving your head or your eyes. If you just look straight ahead and look through your periphery, you can see almost 180 degrees to the side of you. It's pretty wild. But Owen is taking about 10 degrees of my field of view right now with my fist. Now, There's obviously lots of other space around him, right? But about 10 degrees is taken up by Owen. If I had a 300 millimeter lens, that means that I could make Owen take basically 100% of my field of view by zooming into him. Basically, what this small number means is that this is the field of view that is made to be 100%. So if it's about 8 degrees of your field of view, with a 300 millimeter lens, you can make that small section of your vision take up all of your vision. Essentially, this is like zooming in. That's what most people think of as zooming in, right? Yes?
I got a Band-Aid.
Sure. What'd you do to yourself?
I just picked the scab, I think.
Oh, interesting decision. I do. Yeah. Well, what happens is when you're a dad, you end up carrying around stuff like this because kids get wounded all the time. So, yes, I just
My
have.
dad just doesn't care.
I mean, I didn't say that.
Thank you.
Actually, those are small ones. There you go, it's a big one. Okay, so this idea of zooming into something is, I kind of wish that photography worked like this, that it gave you field of view numbers instead of this kind of arbitrary millimeter thing that it does. But for whatever reason, lots of historical reasons, it doesn't work like that. So you have to kind of learn what these field of view things mean and as they relate to lenses. Now, I'll show you, and you'll get lots of practice with this. So it's not the kind of thing that you have to like memorize. That's not what I want you to do at all. Now, if we get all the way down here to an 8 millimeter lens, an 8 millimeter lens is like a fisheye lens, or kind of like what you would see on like a GoPro or something. They can actually show you a full 180 degrees of a scene, which can be really crazy looking. Nowadays, there's things called Insta360s. There's a company that makes them that takes a couple of lenses like this and puts them together front to back so they can see 360 degrees around them at all times, which is kind of cool, kind of weird. There are also some really weird specialty lenses called fisheye lenses that can let you go beyond 180 degrees. So I've seen one that can do up to 240 degrees, which is kind of weird because then you actually start seeing the camera itself in the shot of the camera. So like as you're like taking a picture, you can see the sides of the camera in the picture itself, which is really disorienting and is sort of confusing to think about, like how that's possible. But lenses, which is the thing that we're talking about here, is what controls the field of view. Now, I should not talk, I should just show you at this point because it's going to make a lot more sense. So my camera up here is obviously showing a live view of class. Oh, that's fun. Why is that doing that? Do I have a microphone connected? Because it's coming out of there. I'm not 100% sure how that's happening. Oh, well, it doesn't. Oh, I know why. It's because of this. Here, I'll just unplug this microphone and then it won't do that. So, there we go. So, the shot that you see right now is coming from this lens, which is a 16 millimeter field of view, or 16 millimeter lens. So it's showing us, 80 degrees probably of field of view. If I were to zoom in a little bit, I can have a smaller field of view, but that smaller slice is made to appear larger, right? That's 24 millimeters. This is 35 millimeters. Again, we're zooming in. Magnus is going to get to be the center of this shot, it would seem. I'll make him just all the way the center of the shot. 50 millimeters. So now we're talking about probably 30 degrees field of view from the camera's perspective. And then the maximum zoom on this one is a 70 millimeter. Okay. So wanting to grab Sven back there instead, that's fine. There we can go. We can make it focus on him. So this is what most people think of as zooming in on somebody. What it actually is decreasing the field of view. Instead of it being this super wide look, it's actually becoming more narrow field of view. but it's making that narrower field of view larger. Well, how is that possible? Lenses use optics, basically pieces of cut glass. Lots of mirrors and reflectors and all kinds of really interesting technology to bend light. So a lens, this thing, is really taking light from whatever it's looking at and is gathering it and focusing it and sending it into the camera out the other end. Lenses are actually by far the most important part of a camera. And we'll talk more about this in the coming days, but people talk about cameras as being good. That's actually kind of stupid. Cameras aren't usually anything special. Lenses are what are special. Lenses are what actually make the thing happen. Yes?
Does it matter, if you have a good lens, does it matter how much you zoom in? Will the quality stay the same?
Ooh, that's a great question. So I'll tell you that expensive lenses are expensive for a reason. Good quality lenses are really expensive because even as you zoom in, they stay really sharp, meaning you have a lot of detail that still remains. So this is a pretty good lens. It's hunting a little bit right now because you're backlit, but you can see a lot of detail in your hair and stuff. You can read your shirt really easily. We can see, details on your face pretty simply. If I zoom back out, sure, we don't see those details as much, but we still have a pretty detailed image. So lenses are what people talk about as resolving something, where you can actually get detail from them. Sometimes people like to use purposely crappy lenses. Here, I'll put a purposely crappy lens on this thing for you so you can see what I'm talking about. This is something I made. This is the lens from a 35 millimeter disposable Kodak film camera, which I took a knife to and cut the lens out. It's a piece of plastic lens. It's garbage, terrible lens. But it cost me about $5 to make this lens, and I'll take this $800 lens off my camera here, and I'll put on this $5 lens, and you can see the difference. Now, first off, this has no zoom. This is just what it is. And what it is, well, it's not great. Here, you move your foot for me. Oh, that's that's this cable. Okay, now I got the cable even more in the way, right in the middle of it. There we go. Oh. So this is, oh gosh, dang it. Where are we routing this cable? Is that, oh yeah, that's this. We don't need that. Okay, there we go. So this piece of crap plastic lens is pretty wide. That's probably like a 40 or, actually that might be more like a 25 millimeter lens. So it's probably like an 80 or 90 degree field of view, something like that. Doesn't really matter. But you can tell that the detail that's present here is a lot lower. It's the exact same camera. I haven't even turned the camera off. But the reason why it looks fuzzier and blurrier and less like good is because this is a piece of crap lens. And that's okay. That's what this is, just meant to be a $5 disposable lens. I use this very often when people want old-fashioned looking pictures, but I don't want to use an old camera. I want to use very modern camera, but I want it to look old-fashioned. Instead of like putting a filter or something on it, what if I just use a crappy disposable lens to get that look? And hey, look, that's what it looks like. There's no focus to this either. It's just what it is. You can't even focus the thing. It's just, well, I'm here doing bad lens things. But some people like this look, so it's fine. So this little lens is doing the exact same thing as this giant lens. It's taking light and focusing it onto the camera. It's just this big one does so with a much sharper and nicer looking image and lets me zoom. Does that answer your question? Cool. And notice that like that's about the same field of view, but notice how much nicer the image looks than this piece of crap plastic lens, right? Same camera, just better lens. So lenses come in two very rough families. There are zoom lenses, and then there are prime lenses, okay? This is a zoom lens. We have 4 of these. These are class lenses. They're very nice. And these will let you zoom in from 18 millimeters all the way to 50 millimeters. That means that you can make things a little closer up, or you can get a nice big wide shot if you want. And you can change that just by rotating this ring on the outside. This is instead a prime lens. It has a ring on the outside, but this is not for zooming, it's for focusing. This is set to 1 focal distance. This one is a 50 millimeter lens, which means that this lens doesn't zoom. If you want it to look larger, if you want your subject to look larger in your picture, you have to physically move closer to them. So there is no zooming, you actually have to bring the lens closer. Prime lenses like this are the standard when you're doing like filmmaking, like actual real movies. Real movies don't usually use zoom lenses, they use prime lenses. Now why, we could talk about later. We're not going to talk about the fancy stuff with lenses today. But the short answer is they look better. They look a lot better. So I'll show you this. This lens, so I'll set this to 50 millimeters. That's what this lens looks like at 50 millimeters. Okay? So kind of remember what this looks like. I'm going to take this lens off and put on this prime lens that's also at 50 millimeters. And you're going to notice that it looks pretty different. Now, first off, it's squished for reasons that we'll talk about later. It's also out of focus, which means I need to focus it myself. There we go. But the character of the image is really different. Now, partly that's because this is an anamorphic lens for people who know what that means, which is why it's so squished. You could do some special stuff with it. But it also has a really interesting kind of look to it. And that look of a lens is what people who are making movies really care about. It's not just the focal distance, it's the character of the lens itself. It also changes the way people look on camera. Lenses can affect the way people appear. I'm going to show you what I mean by that. I had my 3rd year AV kids go out this morning to the football field and shoot a video for me. I'm going to show it to you so you can appreciate this. Okay. This is in your AV drive, so if you ever want to go back and consult this later, you can do that. All right. Where did I put that? Focal length demo, hello. There it is. All right.
Focal length 18, 1 yard. Focal length 18, 5 yards.
Oops.
Focal length 18.
Need to turn off my camera for this to work. Sorry.
Wait, I have a question.
Yeah.
Why does it go white whenever you take off the lens?
Because there's no focus. It's just capturing all the light in the room. The lens that's doing all the focusing doesn't have anything to focus on. So I had Max and a couple of kids go out and shoot this for me. So at the bottom left here, it tells you the lens that they're using and at what focal length it's at. So yes, by the way, the company that makes this lens is called Sigma. Sigma, the company, has been around for about 100 years, way before, stupid meme culture existed. So this lens is what they're using, and they're zooming in slowly as they go. So on the bottom side here, it'll say, oh, this is this lens at 18 millimeters. Eventually, they switch lenses, and I'll show you what that looks like too. This will probably explain a lot of stuff.
Focal length 18, 1 yard. Focal length 18, 5 yards. Focal length 18, 10 yards. Focal length 18, 20 yards. 18, 50 yards. Focal length 24, 1 yard. Focal length 24, 5 yards. Focal length 24, 10 yards. Focal length 24, 20 yards. Focal length 24, 50 yards. Focal length 35, 1 yard. Focal length 35, 5 yards. Focal length 35, 10 yards. Focal length 35, 20 yards. Focal length 35, 50 yards. Focal length 50, 1 yard. Focal length 50, 5 yards. Focal length 50, 10 yards. Focal length 50, 20 yards. Focal length 50, 50 yards. Focal length 70, 1 yard. Focal length 70, 5 yards. Focal length 70, 10 yards. Focal length 70, 20 yards. Focal length 70, 50 yards. Length 100, 1 yard. Focal length 100, 5 yards. Focal length 100, 10 yards. Focal length 100, 20 yards.
What are y'all doing?
Focal length 150 yards. Length 135, 1 yard. Focal length 135, 5 yards. Focal length 135, 10 yards. Focal length 135, 20 yards. Focal length 135, 50 yards. Focal length 200, 1 yard. Focal length 200, 5 yards. Focal length 200, 10 yards. Focal length 200, 20 yards. Focal length 200, 50 yards. Focal length 350, 1 yard. Focal length 350, 5 yards. Focal length 350, 10 yards. Focal length 350, 20 yards. Focal length 350, 50 yards. Focal length 350, 100 yards.
So that last shot, he's 300 feet away, 100 yards away, and you're still getting a usable, like, full body shot at 300 feet, right? This last one where he's 50 feet or 50 yards, 150 feet, that's like, you know, that looks like an interview shot, except that they're standing 150 feet away from them. Yes.
How expensive was that lens?
Well, I'm glad you asked. It's this one right here. This is a $1,000 lens. The lens, not the camera. The lens is $1,000.
How much is the camera?
They're shooting on an A61, so $700, something like that. Now, this is what I'm after, is that the lenses, when it comes to cameras, camera bodies, sure, they matter. Like, this is the thing that takes the picture and stuff. But when it comes to creating the look, creating the image, it's all about the lenses. Good lenses will last you forever. Camera bodies, they get broken or they go obsolete really quickly. Oh, a new camera body that can do fancier stuff comes out. Okay, great. But if you have lenses that are good, good lenses are always good. I've got a couple lenses back there that are 70 years old that still look amazing because they were amazing lenses then. They're still amazing lenses now. You're talking about cutting glass, okay? You're shaping light with cut glass. There's not really like a better way to do that. You can do it to like a finer degree. You can cut them with, you know, better machines so that they're cheaper to manufacture. But once it's a good lens, it's a good lens. So that's why I care about the camera bodies. If I see a broken lens or a dropped lens, I get real upset because this is actually where the value is at, because this is where the image is created. Now, we as a class, I own one of these myself, but we as a class only own one of these. This is called a super telephoto lens. And it's that because it lets you do this. Okay, that shot is at 50 yards, 150 feet away, and it's super clear. You can still see the hair, right? You can still see peach fuzz on Max Stolberg's cheek at 150 feet, right? It's an amazing piece of equipment. This is also why real cameras are never going to be beat by phone cameras, because phone cameras, they can't do this. Phone cameras are getting really, really good, like actually really amazing. Especially when you're doing video stuff, they can do some incredible things. But when it comes to getting really sharp images at a super long distance, there's really just no way to do it with the tiny little crappy lenses that exist in a phone. So I showed this picture a couple days ago. I don't remember if it was this class or the other class, but somebody asked how I got this shot. Like, how is that possible? Well, the answer is I used my telephoto lens, and I was just on the bank on the New Albany side of the river during thunder, and I happened to be in the right place at the right time to be able to capture this as they were, blasting past at, 400 miles an hour or whatever. And it's not a trick. It's just a really good lens that let me do this. And people were like, well, but you can't get a picture like that with your phone. You're right. You can't get a picture like this with your phone. Now, people say, but I can zoom way in with my phone camera. Yes, you can. Let me show you what I'm talking about. Because when you see it, this might make some sense. Start to make some sense. Okay, so there's a thing called digital zoom. Now, this lens, okay, is set to 16 millimeters. That's that nice wide shot. Would you mind hitting the lights for me just so we can get a little bit more light in here? I'm going to not zoom in with the lens. I'm now going to zoom in with the camera. This is what's called digital zoom. Okay, I'm going to digitally zoom all the way in here. How does that look?
I don't like that.
Okay, a digital zoom is, instead of using the glass to zoom in, it's essentially cropping in on the picture. So it's making pixels bigger. Oh, you want to zoom in to see more, make this image seem larger? Okay, we'll make that pixel bigger. And you just keep making that pixel bigger and bigger and bigger. And sure, it gives you the look of zooming in, but look at this. So here, I'm going to get this actually centered there. Okay, so that is a 4x digital zoom. Now I'm going to unzoom that. And now I'm going to use the actual optical zoom and zoom in about the same. Do you see the difference?
A little bit.
That is why your phone can't take pictures like that. In order to get a 4x optical zoom, you need a piece of glass that's at least this size. Where are you going to put that on your phone, right? If you want a 10 times optical zoom, what this can do, you need that much to be able to do that. Oh, but phones will be able to do that. No, physics says no. When you're talking about lenses, you're talking about physics. Optics is a branch of physics. And there's no magic, okay? You can't just magically make things look better while making the thing physically smaller. If you want to have a physical optical zoom, you have to have physical space to do it. You have to have room. So if you want a 10x zoom, like this lens, you need something that's this size. And obviously, this looks kind of silly, right? When the lens itself is bigger and heavier than your phone, it doesn't work. But this is why. You can see the difference. So that shot is 4x optical zoom. You want to see what the telephoto in here looks like? Because we can get pretty crazy with it. Let's get crazy. Yeah, right.
I just happened to be walking by and heard this. And
I'm glad. Oh,
Stop in. Now I want to go buy a camera.
yes. Yes, you can borrow ours anytime you want. There's a big old smudge on the front of this.
This is how
But
you get all those good baseball shots.
this is how I get those good baseball shots, yes.
Mine are awful on my phone. Yeah.
Okay, so here comes this lens. This is at 70 millimeters to start with. Okay, so it's a little more zoomed in than what we just saw for 50. But we've got a lot more room to go. Here, I'm going to raise this up just a touch so we can actually zoom into your face. Yes, yes, yes. Thanks for your shoes. Okay, here we go. Whee! Okay, yeah, get your feet down. We're not trying to get your shoe here. We will just go all the way into 350. Why not? Okay, so this, in comparison to what we were at before, where we were at about 16 millimeters, this is now 350 millimeters. And notice that there is no pixelation here, right? You can see his eyelashes, no problem, right? Now, from here, I could do a digital zoom if I wanted to really, really get crazy with this. I wanted to be able to see his pupil at this distance, that's probably 15 feet, and I want to be able to see a close-up of your pupil. Sure, no problem. Now, that's a partial digital zoom, but yeah. So this is what I'm talking about. Pull your phone out. Okay, you are going to use your phones a little bit today.
Cameron, can you get back for me, please?
And if you open up the camera app on your phone, you're about to learn some things about what your phone is tricking you with. Now, if you've got a modern iPhone, first off, maybe you've wondered what is going on in the back here. You probably figured out, oh, those are lenses. Yes, they are lenses. Each of these 3 different things, or 4, or 2, or 1, or whatever, are different lenses. If you put your phone on the camera app to 1x, you're using the main camera, the main lens. Now, what's actually going on inside of your phone is that they don't have room to switch lenses the way that I am doing here. So instead of having different lenses, there's actually 3 different cameras that have their own permanently attached lens. So when you're at 1x, if you look, that's usually what's called a normal field of view, meaning that it's about the same as what your eyes are, somewhere between 24 millimeters or to 40 millimeters of focal length. Usually right around 35 is what they try to emulate. That's about our normal field of view. So if you hold this thing up to your face and then kind of put it down, you can see that at 1x, the camera is seeing essentially your same field of view, usually right around 30 millimeters, 35 millimeters. Okay? Now, if you have a 3x camera, which most iPhones and Androids will have a 3x dedicated camera, that's switching to a different camera. The 3x that it's referring to is triple the millimeters. So this is usually right around an 85 or a 90 millimeter lens. And because of that, it's got about a 20-degree field of view. It's way more zoomed in. That's not digital, that's optical. That's an actual different lens that's being used. And so that doesn't have any pixelation or anything. It should look pretty nice. However, if you zoom in past there, that's where the grossness starts to happen. So if you zoom to, 20 times, now you're talking digital zoom. And this is where the gross, well, mine does. Yours may not. Some do, some don't. Some Samsungs go to 100, which 30, yeah. Mine has a preset to 30 as well, but I mean, it looks like trash. And that's because this is a digital zoom. It's just cropping in pixels. It's making the pixels look bigger. And very quickly, digital zoom turns to garbage. It just looks terrible. So getting a shot like this with your camera phone using digital zoom, impossible. Oh, but eventually it'll be possible, right? No. I mean, sure, you might be able to put some AI slop on top of it, but actually getting a shot like that with a tiny little camera like this, it's physically impossible, meaning physics will limit you from being able to get that with this. It's just not a thing that's possible. Now, the often referred to 0.5, or on my phone it's a 0.6, which is funny. That is an ultra-wide field of view. Basically, a really, really wide angle field of view. Usually it's trying to do something closer to 150 degrees. So if you have a 0.5, then what you're really seeing is a much wider field of view, right? Now, people think that this looks kind of funny. That's because it does look kind of funny. Super wide angle shots distort images.
He just threw my phone on the ground.
Okay, let's keep our hands to our own property, please. So sure, if you turn around the selfie camera and you put it on ultra wide and then you put it, kind of in a funny spot on your face, you can get really distorted views of your face. That's just because that's how lenses work. All lenses distort a little bit. Now, to kind of demonstrate this, I want to show you, I'm going to go back to Max's face. Oops. So I'm going to go back to Max's face. I'm going to pause it in a couple of spots so you can see something. So for those of you who like to take pictures of yourself, you might learn something here. Okay, so this shot of Max at 350 millimeters, so you're talking about like probably a 5-degree field of view, looks really different than this exact kind of shot from him when he's at 18 millimeters. That's about the same size, right? His face is about the same size. But what do you notice about his face?
His job.
Huh?
Someone said his job.
Well, do you notice that his face looks wider?
Yeah.
This is not because he gained 20 pounds as he walked backwards. It's because optics, lenses, distort things. All lenses do. Even if they're like incredibly amazing, expensive lenses, because of what is happening inside of the lens itself, there's always going to be distortion. When you're taking pictures of people, using wide-angle lenses has a tendency to make people's faces look much, much wider. Here, let's put your phones off. You'll get a chance to play with it in a second, but you're not playing with it right now. So, if you're trying to take a picture of somebody and you're on a wide camera angle, you're going to make their face appear wider. That thing that most people never ever want to have happen. As opposed to if you use a much longer lens and you want the shot to look a little nicer and have a person's face look narrower, you shoot it with a longer lens and have them stand a little further back. And that makes people's faces look slimmer. Again, this isn't editing, this is optics. It's just the way cameras work. So if you're trying to take a really great looking picture of somebody, certainly don't use the 0.5 camera, the wide angle camera, or the 1 or 2x. Use the 3x camera, the longest zoom you've got before it turns into digital zoom, and have them stand further back. And you'll get a way nicer looking shot. Well, how do you know that's true? Well, you're going to know it's true because we're going to go out and do it in a few minutes. That's what I want you to try and see what I'm talking about. It's one thing for me to say it, it's another thing for you to see it, right? Which is what I'm going to have you do. So you're basically going to kind of make like your own little version of this video where you can see what people look like at your different camera focal lengths on your phone. Okay, questions about this before I move on to the next little topic? Okay. Related to this is resolution. So, have you heard the term HD before? Have you heard the term 4K before? Have you heard, oh, this is a 48 megapixel camera? Have you ever heard megapixel as a thing before? Okay. So, I want to talk about this because this is always surprising to people. This panel is a 1080p panel, okay? Full HD. Great. The video that I'm playing was actually shot in 4K. Cameras can shoot in a way higher resolution. 4K is literally 4 times the resolution of HD, meaning that I could get the same look if I had 3 more of these TVs and I arranged them in a big square and I played this back at 4K, it would be just as sharp as it is now. Because this video file that I'm playing has 4 times more resolution than this screen is capable of displaying. 4K means that there's more pixels. 1080 more pixels than 1080. Well, how many more? Okay, so full HD is 1920 by 1080. That means there's 1,920 pixels in a line this way. By 1080, which is 1,080 pixels this way. So essentially, this screen is a grid of 2 million pixels. Roughly 1920, 2000, by 1080, roughly 1,000. You multiply 2,000 by 1,000, 2 million. Not add, multiply. Not the same thing, not even close. So this screen has about 2 million pixels on it. A 4K screen has 8 million pixels. So there are more pixels to show you more information. Now here's what's wild. People are like, oh yeah, 4K, that means it's instantly better. No, it doesn't. You go to a movie, like an actual movie, at an actual movie theater, and you get that giant screen, not an IMAX, but just like a regular movie screen. Okay, they're usually 15 to 20 feet wide. That's a 1080p image. And if you're sitting far enough back, it looks great, looks incredible. Now, if you sit way up in front, you might occasionally be able to spot a pixel here or there. Now, if you go to a IMAX, that's more, usually it's shot in 4K and is shown in 4K. But if you're sitting far back away from the screen, guess what? You can't tell. You literally can't tell. Now, here's what's going to really blow your mind. Full HD, 2 million pixels. There's another way to say 2 million pixels. Do you know what it is? 2 megapixels. 2 megapixels. 4K, 8 million pixels. Guess what you can call that? 8 megapixels. This camera can shoot in 24 megapixels. Some phones are advertising that they have 48 megapixel cameras. Mine supposedly has a 48 megapixel main camera, which, by the way, is a bunch of marketing garbage. Like, it's super stupid. 48 million pixels? This is 2 million. The screen in the auditorium, that's a 4K screen. That's an 8 megapixel screen. It's 20 foot across. Okay? It's 20 foot across. And people are like, oh yeah, my phone has a 4K screen. Why? That's really stupid. At the distances that you look at your screen here, you'll never be able to tell, ever. Because your eyes can't see that finer resolution. Well then, why does your camera need to have a 24 megapixel sensor on it? Well, the short answer is, it doesn't. Old cameras, point and shoots, like the ones that are really popular right now. You see people using these all the time. This little guy from the early 2000s, which if you're on Instagram, you'll see people are trying to find cameras like this and buying them for crazy prices because they like the way they look. This thing, I think this is a 5 megapixel. Yeah, it's a 5 megapixel camera, which means this 20-year-old point and shoot camera can take a picture that will fill not a 1080 screen, a 4K screen perfectly. And this thing is 20 years old. It is only a 5 megapixel camera. So when people say, but oh, this is a garbage camera, it only has 5 megapixels. First off, they don't know what the hell that means. In reality, they don't. Now you do, but they usually don't. And also, they've been marketed to think that a bigger number better. Bigger number, not better. Okay? 2 megapixels that you're looking at right now. You go to an IMAX theater, 8 megapixels. That's it. So wait a second. Why does this camera, if it takes a picture, not look as good as my camera right here? I've already told you the answer. Why? The lens. It has 100% to do with the lens. The lens on here is probably plastic. It's probably garbage. Okay, I don't know that, but it probably is. Does that mean that it takes bad pictures? No. You can take cool-looking shots with bad lenses. Like, that's what Instagram does right now. It's just filled with lo-fi pictures that people like that are cool-looking, that are taken with bad old gear. Does that mean they're bad pictures? No. Remember, photography is art. That doesn't mean anything. It's okay. You can take beautiful looking pictures with crappy cameras. You can take incredible pictures with your phone if you know the limitations. Now, can you take like crazy high resolution pictures and video at huge distances? No, absolutely you cannot. But can you take amazing looking pictures and video at a close distance? Absolutely. Absolutely you can. So understand the limitations of what the gear are and don't fall for marketing tricks. I had a kid bring in an older point and shoot camera from one of the other classes that had a 10 megapixel camera sensor on it. They're like, oh, does that mean that this is like a bad camera? 10 megapixels is more than 4K resolution. You can take a picture with that and even crop in a little bit, and it'll still perfectly fill these 4K screens and look amazing. So if you take a shot with that camera, you can get all the resolution you need, because resolution really doesn't mean much. That's the main thing I want you to pull away from this today. Resolution is Stupid. Nobody should really care about that. You can go out and buy, Hasselblad sells 100 megapixel cameras for photography. Why? What are you going to possibly do with that? Oh, we're gonna make big prints. Okay, 24 megapixels is enough for me to make a billboard-sized image. That's not a joke. If I wanted to make a picture the size of a billboard that you see on the highway, 24 megapixels is easily enough to do that. Print, okay? 24 megapixels. What am I going to do with 75% more pixels? Nothing, literally nothing. It's a marketing thing. It's what people use to try to sell cameras. When what they really should be trying to do to sell cameras is put better lenses on the thing. That's what actually matters. So, questions about this? I feel like you should have questions. No? Okay. Here's what I want you to do. We're going to go out just to the courtyard today. We're not going to go anywhere else, just the courtyard. And I want you and a partner with your smartphone to take pictures at a bunch of different focal lengths, whatever you've got on your phone. And you can try digital zoom too to see what I'm talking about with how that looks. And I want you to just take pictures of a person. I will also make one suggestion to you, not to have the background, not to have a person stand right up against a background. Have them stand out a little bit away. I'll tell you why next class. But you'll be surprised by how much nicer of a picture you can get with that. Okay? So, if you don't have a camera, if you don't have a phone with a camera on it, it's not a big deal today. You just get to be people's model instead. Okay? All right, let's go. Out we go.
Do we need our passes?
Nope, don't need your passes. We're just going to the court.